Theorem 1. Logarithm of mn to the base a is equals to log m to the base a plus log n to the base a, where m and n are positive numbers. Of course, a cannot be equals to 1 and it should be positive. How are you going to prove it? Simple. I assume the right hand side log m to base a as x and log n to the base a as y, and converting logarithms into exponentials, and then we try to prove the result. Let's see that. Log m to the base a is equals to x, okay, implies m is equals to a to the power of x. When you remove the logarithm, m is nothing but a to the power of x. Similarly, log n to the base a is equals to y implies n is equals to a raised to y. Clearly, we see that m multiplied by n is equals to a power x into a power y. As the bases are equal, you can add the powers. So, you will be getting that is equals to a to the power of x plus y. So, mn is equals to a to the power of x plus y, and therefore log mn to the base a is nothing but x plus y. Log mn to the base a, x plus y. But x is equals to log m to the base a. X is nothing but log m to base a, and y is log n to the base a. Hope it is clear. So, finally, log mn to base a is nothing but log m to base a plus log n to the base a.